All right, today we're cracking open the toolbox for talking to databases. We're talking about SQL. We're going to master the art of asking just the right questions to pull out exactly the information you need. So, I want you to think of yourself as a detective, okay? Every database is like an evidence room, just packed with clues and information. But how do you find that one crucial piece of evidence that's going to crack the case? Well, you need the right tools to ask the right questions. And that tool is SQL. You know, pretty much every single thing you can do to a database falls into one of four buckets. It's called CRUD. You can create new data, you can update it, or you can delete it. But honestly, the one you're going to be doing most of the time is just reading the data, just pulling it out to look at it. So that's our entire focus today. And the command for reading data is actually super simple. You just have to tell it two things: what columns you want to see and which table you want to get them from. That's it. At its heart, every question you ask your data is going to follow this simple what and where logic. Okay, so here it is. This is our evidence room, the customers table. It's got everything we have on file: names, cities, countries, the whole shebang. This is basically our full list of suspects before we've even started our investigation. It's a lot to sift through, right? So let's ask our first question. We don't need all that other info. We just want a simple list of our customers' first and last names. See what we're doing here? We're telling the database, just select those two specific columns from our main customers table. And voila! Here's what we get back. It's exactly what we asked for and nothing more. We've successfully filtered our view down to just these specific clues we needed, a nice, clean list of names. This is the fundamental power of using SELECT. Now, quick pro tip here. You could just use a wildcard, like a star, to grab everything from the table. But a good detective is precise, right? Asking for only the columns you actually need is way more efficient, it's faster, and it keeps your application from getting bogged down with a ton of useless data. Okay, so we know how to select our evidence, but right now we're still looking at every single customer. To be a good detective, we've got to narrow down our list of suspects. This is where the real interrogation begins. And this is where the where clause comes into play. Think of it as our primary interrogation tool. It lets us add a specific condition to our query, and it just filters out all the rows that don't match our criteria. This is how we go from a giant list of suspects down to a handful of persons of interest. Let's try it out. Our next question is very specific. We want the names and the country, but only for customers who are from Canada. We're basically telling the database, look, show me the evidence, but only if it's connected to Canada. And boom, look at that. Our huge list of customers from all over the world has been instantly whittled down to just the ones in Canada. We've successfully filtered our evidence. This is incredibly powerful stuff. The where clause can also use all sorts of different operators to ask more complex questions. You can check if something is equal to a value, not equal to it, less than, greater than. You get the idea. These are the basic building blocks of any good interrogation. And you can make your questions even more powerful by combining conditions. Using and is really strict. It's like saying the suspect must be from Berlin and from Germany. Both have to be true. Using or is more flexible. You're looking for anyone who meets at least one condition, like being from Canada or the USA. Now, sometimes you don't even need all the results, even after you've filtered them. You might just want a quick sample. For that, we use the limit clause. It's like telling the database, hey, just show me the first 5 pieces of evidence you find. See what happens here? Even though our search for Canadian customers could have returned a bunch of results, adding limit 5 tells the database to just stop after it finds the first 5. It's a super simple and effective way to control your output. So we've found our clues, we've narrowed them down, but right now they're just in a jumbled mess. The final step for any good detective is to organize that evidence so we can actually make sense of it all and start spotting patterns. And we do this with the order by clause. We're going to take our list of Canadian customers, and now we'll ask the database to sort them alphabetically by their city. By default, it sorts them from A to Z. This is like organizing your case file so you can see things clearly. And this shows the result perfectly. It's the same data we had before, but now it's beautifully organized. We can immediately see all the customers from Edmonton are grouped together, then Montreal, and so on. This simple act of sorting makes the data so much easier to understand and analyze. So if there's one thing to remember, it's this logical order. You build a query in 3 steps. First, You get the data, say what you want and from where. Second, you filtered that data down to just what you need. And third, you sort the final results so they're easy to read. Get, filter, sort. Now, you might be thinking, this is cool, but why is it so important? I mean, why go through all this trouble inside the database itself? Let's talk about that big picture. This is a really, really common question. Why not just tell the database, give me everything, pull all of it into my Python code, and then do all the filtering and sorting there? I mean, it seems easier sometimes, right? Well, the answer really comes down to working smarter, not harder. When you filter inside the database, you only send that small amount of data you actually need over the network. Plus, databases are these highly optimized engines built for this one job. They are incredibly fast at filtering and sorting. And the result? Your application runs much, much faster. You've got to let the database do the heavy lifting it was designed for. So we've covered the fundamentals of being a data detective. You know how to select your evidence, how to interrogate it with filters, and how to organize your case file. You now have the core tools to start asking some really interesting questions. So the only question left is, what secrets are waiting for you to uncover in your data?